Fish migrate uprivers to reach spawning grounds where they lay their eggs. The number of fish that survive the trip can be modeled using a sine function when tracking data from year to year. The table shows the number of fish in thousands that survived each year. In your model, let x equal the number of years since 1996 and y represent the fish in thousands. Notice 1996 is the first year, and therefore x equals 0 represents 1996. A. Use your calculator to plot the data, which we'll do using Desmos. Then use your calculator's regression tool to find a sinusoidal function that best fits the data. Round all values to the nearest tenth. Let's go to Desmos. Click on Add Item and select Table. There are 16 rows of data, and therefore we enter x equals 0 through x equals 15 under x1. In the second column, we enter the number of fish in thousands. To see the scatter plot, we'll have to adjust the window. Let's first zoom out. Click, hold, and reposition the coordinate plane, and now we'll adjust the axes manually. Click on the wrench. Let's have the x-axis go from -4 to 20. Step of 1. The y-axis already looks pretty good, but let's change it to go from -10 to 60 with a step of 5. Click the wrench again to close the menu. Notice how the scatter plot does resemble a sine function. And now we'll perform regression in cell 2. Click in cell 2, enter y1. Instead of equals, we use tilde. To access the tilde, click on the keypad, click ABC, and the tilde is here at the bottom. Close the keypad. Let's find the equation in the form of A times sine of B times the quantity x1 minus C, close parenthesis, plus D. Notice the values of A, B, C, and D show below. Let's enter our regression equation with the values of A, B, C, and D rounded to 1 decimal place in cell 3. And let's go ahead and use function notation here because we'll have to evaluate the function in the last part of the question. Let's enter f of x equals, again we're rounding A, B, C, and D to 1 decimal place, so we have 16.8 times sine of 0.5 times the quantity x minus 5.8, close parenthesis, plus 42.3. Let's go ahead and turn off the regression equation by clicking on the black circle on the left. I'm going to go ahead and change the maximum on the y-axis to 70 instead of 60. I'm going to click on the wrench and adjust the 60 to 70. That looks pretty good. And now let's go back to our question. For part A, we use Desmos to plot the data. Part B, here's our regression model. Notice here I'm using y instead of f of x. For part C, to preserve the fish population, the Department of Game and Fish will suspend fishing if the number of fish that survive the migration falls below 34,000. Using the model from part B, will fishing be suspended in the year 2030? What is the predicted number of fish to survive that year? Let's first determine the value of x for 2030. To determine the value of x, we subtract the base year of 1996 from 2030, and therefore we use x equals 34, meaning we need to determine y of 34, or, going back to Desmos, f of 34, and then see if that value is more or less than 34,000. Going back to Desmos, because we have the model in as f of x, we can simply enter f of 34 in cell 4, which rounded to 1 decimal place would be 59.1. Remember, that means 59.1 thousand fish. So again, f of 34 or y of 34 is approximately 59.1, which means the predicted number of fish to survive is 59.1 thousand, so fishing will not be suspended because 59.1 thousand, or 59,100, is more than 34,000. I hope you found this helpful.